In this video, we're going to talk about our AC power measurement device, the Quarch IEC mains power analysis module. This device is designed to measure AC power, so that's what comes out of the wall, out of the plug, and goes straight into your device. And it can measure any device up to 10 amps of current. So we'll plug it in and we'll get started. Here I've got my mains power lead, a very common connector which goes into the front, and then I can simply plug in my devices into the back. Now here I'm running a PC and a monitor, so I will plug them into my two ports here. Power up my device, plug it in on USB, although we can also use Ethernet, and we're ready to go. I'm going to look at the power up of this device. So I'm going to run my test software on an external laptop, but we can also run it on the device under test as well. Right, so I'm going to start up Quarch Power Studio. And I've got a list of devices here. This laptop is on our network, which means there are many Ethernet devices in the building which it's talking to, but I can see in the list here that the mains PAM is here. We can start recording. And what I'm seeing here are, we have three outputs on our device, L1, L2, L3, and I can clearly see them split out in our software here. So we can see the voltages, both instantaneous and RMS. We can see instantaneous and RMS currents as well, and that gives us all the other measurements that would be of interest to us. When I start up the PC, I can see that I start to get some power consumption here, and I'm starting to see some changes. So we are streaming in this example. So we are recording at fast sample rate, every 125 microseconds we're taking a sample, and we can do that indefinitely. So we can run this for hundreds of hours, we can script it, and we can collect data, an enormous amount of data with the product. Or we can use our graphical interface here. And whilst we can see a very long range, we can also zoom in very tightly. So what I can do is I can double click on my timeline, and I can start to zoom in on a single cycle, mains cycle, that's the voltage going up and down, and see the current consumption of the device. In switching power supplies in modern electronics, consumption is not very constant. Current is not constant within it, and that gives rise to things like harmonic distortion of the power supply. So it's important to be able to measure that, and we can do that. We can look right into a single cycle and find out when the FETs are turning on, which is causing spikes in the current, and whether we may have some problems in the bigger system. We've set up this example with a PC, but this could be any device. So this could be a phone charger, it could be a domestic EV charger, it could be a dishwasher. It doesn't really matter. What's important is that we can capture it very safely. There's no clamps and probes, no bare wires, and we can record a lot of data and use that for an automation and analysis.